let's continue our discussion of programming in MATLAB Octave. So today we want to look at plotting in a little bit more detail and look at some of the fundamentals of programming. And this is what makes Octave and MATLAB such a valuable tool, being able to store programs and files, and then then modify those files and run those files. And in particular, we'll look at writing our own functions. So maybe a couple things from last lecture. We talked about using the semicolon to suppress the output from a line. Of course, if you've only got one statement on a line and want to see that output, you can leave the semicolon off. Again, it just affects the display. It doesn't affect the assignment. The assignment always takes place. But if you can actually put multiple commands on a single line if you wish. Sometimes that's convenient when you're working at the command line, or even in a file. But then you have to actually separate the different commands by a semicolon. And then the only semicolon that's optional is the one for the very last command on the line. I guess the other thing here is that you can do assignment using indices from find on either the left or right hand side of an equal sign. You do have to make sure that the number of elements on the right hand and left hand side are equal. So in this particular case, we're generating a random vector with 50 elements in it, finding all the values that are less than 0.1, and then actually storing those in another vector. So y would actually be smaller than x here. This command is going to take all those values and replace them with their negatives, okay? And then here we're doing assignment to x. Now it's not going to affect, well, actually let me just show you. I'll pull up, I'll try it with a smaller vector so that we can actually see the results. 1 comma, let's see, 8, okay, and then I'll display that. And then I'll sign here. I'll change it a little bit. We'll look for all the values that are less than 0.2, and then that's the in this particular case, that's the second element, the third element, the fourth element, and then the seventh element isn't showing up, but that one, and then all the others are actually greater than 0.2. So if we do that assignment, y is just going to be those 4 elements. But I can also do this, minus x of I and ds, and this is actually going to replace those elements with the negatives. Now the other elements of the vector, all of the elements that were greater than 0.2 aren't changed. We're only just changing those particular elements. I can also do something like set all of those to a particular constant. Again, it only affects those particular elements. Here's a trick. I can actually delete them by assigning them to an empty matrix, and then that's actually going to get rid of all the elements in the vector that are actually less than 0.2, and then leave the remaining elements. Okay. So let's take a look at actually writing our own functions. So we used some functions last time, the exponential functions, some of the trigonometric functions. The great power in any programming language is actually being able to develop your own functions. Now, we wrote scripts last time. Functions are put in a file, so they're similar to scripts. They can have help in them, just like we had help in a script last time. There is one thing you have to be aware of when you write functions. They have to have this keyword function as the first non-comment line in the file. Okay. The other important thing to remember when you're writing your function is that the function name, in this case the function name is stats, has to be the same as the file name. The file name is stats.m. The function name is just stats. So this particular function accepts a single argument, so we pass it a single argument, and now we can use this variable x within our program. So we could call it with, call it anything. You could pass it, a y vector. It doesn't matter what what you call it in the original program, but whatever that argument is within the function that we refer to that particular variable by x. In this particular case, the stats function is has three return arguments: average, standard deviation, and range. And range is actually a vector. Okay, so these individual return arguments might be matrices. In this particular case, the intent is x is a vector, and then the average AVG is the average of this vector. Again, you can call these return arguments anything that you want to in your function. It's just that the name here, when you make an assignment to that, it has to match the return argument here. So let's play around with this a little bit. I've actually got the stats I typed that in here. The end keyword here at the end of a function file is optional. I like to include it, but it's not required. So here we've got the stats function defined. It's in our current working directory. So let me actually generate a new vector of random numbers, maybe with 10 elements, and multiplying it by 10 will give me random variables that go from 0 up to 10 instead of from 0 to 1. Okay. Now, even though stats had multiple return arguments, actually let me call this something other than x, just because that's just to show you can have a different name. It could be x. This will be a completely different. Let me clear all the variables actually. So start with a clear variable space. Define a new y variable, call my stats function. Now when I call stats like this, I only get the value of the first return argument back, and that was actually, if I do help stats, it prints out that help information in the file. And so when I call stats like this, I only get back the average of x. Okay, and then the other thing to note here is in my workspace, I still only have y, and then the answer now is defined. All of the other variables that are used inside the function don't appear outside the function. Again, here the argument that I'm passing to stats is called x. That's the variable I use here when writing the program. And then the return arguments here are defined within the function, but they're not then actually defined back in outside that function. Well, what if I wanted I could also call it like this. Okay, that's also going to give me the same value, which is the average. If I wanted the standard deviation, I have to pass it using this notation. I'm going to use the comma here, but that's actually optional. Now I'm going to get two values back: the average in the y vector, the average of the values in the y vector, the standard deviation, and then also, if I want the range, I have to include all three. You see, for the range, I get back a 2x1 vector. I'm sorry, 1x2 vector that includes the minimum value in y, which should be the 0.30488, and then the maximum value, which is this 8, which is the 8. And then so I've got all three values. So if a function returns three values and you want all three, you have to call it with three return arguments. If you call it without using that, it will only return the first argument. Or if you call it using the first two, it will only return the first two. There is shorthand notation. Let's say you're only interested in maybe the average and the range. If I replace the standard deviation return argument with just the tilde character, I'll get just the average and the range. Or maybe I'm interested in only the range, I can call stats like this. But by default, if you call it without any arguments or just a single assignment to a single variable, you get just just the first return argument back from your functions. Similarly, we could actually call our functions with multiple arguments, x, y, z vectors or x, y, z matrices as well. So, our inputs here are comma separated, then our outputs here, and again, you have to have this keyword function, otherwise MATLAB will think that you've got a script file instead of a function definition file. And at this point, the safest thing to do is put all of our functions into different files. Our stats function into a stats.m file. If you write specialized plotting function, that should go into a specialized plotting.m file, for example. Okay, so here's a bit more detail on that. MATLAB returns only the variables you specify here in this function declaration. We can use other variables in the function. Often we do. I could define a t variable or a w variable, but those definitions would only exist inside the function. Those variables would only be available inside the function and wouldn't be available back in my main workspace. I could also call this function from another script file, and that's fairly common. I don't actually do a lot directly from the command line like I'm showing in this video. I tend to write script files for most of my work so that I can edit them easily and rerun them. But most of my script files call other functions, either built-in functions or functions that I write myself. Okay. So a lot of functions actually will either return multiple return values, or in many cases may even take multiple arguments. Okay, so we have multiple returns or multiple input arguments here, and you can determine like the number of arguments that are passed. Again, you can see this when we do like help size, for example. If you look at the top here, it shows, well, you can call it with just a single argument. You can call it with 2 arguments. It will return either just the single variable here, or you can actually call it with and I do this pretty regularly. If I want, for a matrix, if I want the number of rows and columns, I can do the size of A, and if A is a 10 by 3 matrix, rows would be 10 and the number of columns would be 3. Well, maybe it's a little easier just to illustrate that. So A is random 10 by 3. I'm not going to display the elements. So if I just do size of A, I get back a vector argument containing the number of rows and number of columns. But if I want to assign those individually, okay, I can get the rows and columns separately by calling it like that. If I want just the columns, that's what the second argument is for, the dimension. If I want the number of rows, if I by using a second argument here, I can get just that first dimension, the number of rows. If I use a 2 here, I'll get the number of columns. So there are variations. This is called overloading of the function. I can call it with a different number of arguments, get a different number of returns as well. Okay. You can take a variable number of arguments, inputs, a variable number of outputs. You actually have within your functions, you can determine the number of of arguments that have been passed to the function, that's actually encoded in this special variable called nargan, number of arguments input. Okay, and sometimes when you're writing functions, often when you're writing functions that take multiple input arguments, you'll look at nargan to determine, well, am I being called with one input argument, or two input arguments, or three input arguments based on the value of nargan. And then similarly, narg out is an integer variable that's equal to the number of output arguments the user is requesting. Okay, so here's a little exercise to plot this, create a little function called plot sign. Again, the name of the corresponding file would be plotsign.m. This particular case, there is no return argument. This thing isn't going to return an answer, a value. It's just going to create a plot. But in this case, you're asked to write this function that when you call the function, you call it with a single argument, then it actually will plot the sine wave over the range from 0 to 2 pi, where x goes from 0 to 2 pi, with the particular frequency that you pass. I guess there's one other thing I should point out here, is that when I'm working with functions, I can't run a function. Functions typically expect arguments. So if I hit my little arrow key here, I'll get an error because it tried to run stats, but stats required a single argument, and I didn't supply one. So normally when you're running functions, you'll do like I've done here. I'll have to give it, in this case, here's another vector, and it will return the average of that particular vector. Okay, so you try this exercise, and then we'll come back and continue this discussion.